All right, we're starting Unit 4 and Unit 5 FRQs. This is question 1. If you want to look this up online so you can follow along, this is 2009, number 2. So you just Google AP Statistics 2009 scoring guideline, go to question 2. If your video is really blurry, hover so you're down under the line, on the black line where you do the play and the pause and everything, and there's a little star. Hit that and then increase your resolution. It's probably set on the lowest resolution. If you increase that at least a couple of spots, it'll clear up. It'll stream a little slower, but it will look a lot better so that you'll actually be able to read what's on the screen. If you can already read what's on the screen, then don't worry about it. So this is 2009, question 2. A tire manufacturer designed a new tread pattern for its all-weather tire. Repeated tests were conducted on cars of approximately the same weight traveling at 60 miles per hour. The test shows that new tread patterns enable the car to stop completely an average distance. So an average distance of 125 feet with a standard deviation of 6.5 feet. And that stopping times are approximately normally distributed. What is the 70th percentile of the distribution of stopping distances? So remember, 70th percentile is where you have 70% of your data below that point. And I'm trying to figure out what that point is, and I called it K. So you need your distribution description, which remember is n parentheses mu comma sigma, your probability statement, and then your answer. So they did it the old school way, where you actually figure out what z-score goes with the 70th percentile, and then you calculate x from that. I would not recommend that because we're hip and cool and we have calculators that can do all that work for us. So let's read what they wrote. Essentially correct if the student correctly indicates which distribution is being used, along with the parameters mu and sigma. That's what this is. This indicates the distribution along with the parameters. This is a set notation. You can also write it out if you prefer. So you could do that instead, but this works just as well, and it's faster. And correctly calculates the percentile with appropriate justification. So this is my justification, this is my answer. Let's see, they got 128.4. I got a more precise 128.4086. So these are the 3 components. If you have all 3 of these, you get essentially correct. Oh, and here we have it. It tells us the standard notation. So it looks like they're accepting the calculator command here with the right answer and an appropriately labeled sketch. But an appropriately labeled sketch, I believe, also has to have the mean labeled. Oh, and the standard deviations labeled. So you have to like actually go out and do like the 6.5 and everything. I wouldn't recommend that. I would think that would be more work. This is less work. So calculator notation only gets you credit if you have like a fully detailed drawing. So this is the most efficient way to get your credit. If you have 2 of the 3 components, it's partially correct. If you have the calculator notation with the correct answer, but you don't have a description of your distribution or you didn't label the mu and the sigma, that's partially correct. Less than that, incorrect. Let's move on. Part B What is the probability that at least 2 out of the 5 randomly selected cars in the study will stop at a distance that is greater than the distance calculated in part A? So at least 2 out of the 5, that's a binomial situation. We want at least 2 successes out of 5 trials. So I did binomial. Remember the shorthand for this is B parentheses N comma P. So binomial is 5. We want them to stop at a distance greater than the distance in part A. Remember for part A, that distance we calculated is the 70th percentile. That means 70% is below that point. So above that point would be 30%. That's where I got my probability of success being 0.3. I want at least 2 successes, but my calculator only does less than or equal to. So at least 2 successes is the same thing as 1 minus the probability x is less than or equal to 1. So I'm finding the opposite and subtracting from 1, and I got 0.47178 or 0.4718. To make sure that's what they got. Yep, it's exactly what they got. They did it like the fancy old school way using the actual formula, but this should have all of the required components. Essentially correct if the student recognizes this probability is an application of the binomial distribution and sets up the problem correctly by first finding the probability for P, the probability of success. Yes. So that's what this part is. I recognized that it was binomial. I got my 0.3. This shows my answer and then my calculations. Yeah, so they do some accepting of calculator commands, or at least they did in 2009. But this is much more standardized, and this is what they really want. Calculator notation, you need to make sure you're still labeling specifically your parameters and all of that. If you have these 3 components, though, which is the way you were taught to do it, you should get full credit. 2 of the 3 components would be partially correct. Part C, what is the probability a randomly selected sample of 5 cars will have a mean stopping distance of at least 130? So this is where we have to use the sampling distribution. So my mean is still 125, but now the mean, the sigma of x bar is equal to the sigma divided by the square root of n. So that's where this formula comes from. You can calculate that if you want, or you can just type the standard deviation in directly like that when you do normal CDF. You'll use normal CDF for this. I want the probability x, this should be x bar is greater than 130 equals 0.0427. Let's make sure that's what they got. Yeah, they got 0.0427. They used the old school way of the z-score, which I do not recommend. Essentially correct if the student recognizes the distribution of the sample mean will be approximately normal with the appropriate mean and standard deviation. That's what this is. And the probability is calculated correctly. So I had my sampling distribution, I had my parameters, and my calculation. So you need that as well. I should have put X bar, but it doesn't say anything specific about it. So I'm not going to take off right now, but I would correct it if you made that mistake. Forgot to put my E's. If you're missing one of these components, it should be partially correct. Breakdown is the same breakdown it usually is. 3 E's is a 4 out of 4. EEP is a 3 out of 4. EEI, EPP or EPI or PPP are all 2 out of 4. EII or PPI is a 1 out of 4. Less than that would be 0 out of 4. But hopefully you did pretty well on this question. Come here.